You guys are done writing that down? Do you guys have any questions on anything we did last time? Any questions at all on that? Well, what I wanted to do is go over a few exercises now, using whatever we have covered so far. So let's do that. Example 1. Let's say the question is the following. Evaluate each expression. And you are not allowed to use the calculator when you evaluate the expression, okay? So I am looking for an exact value instead of a value from the calculator. So let's say A, you have 81 to the negative 3/4. Okay? That's what we want to evaluate. So how would I evaluate that? Well, remember that last time we said if I have a real number with an exponent which is rational exponent, right? We will take the root first and then we are going to take the nth power, right? So that means in this case I am going to take the fourth root of 81 first, and then I'm going to raise it to that negative 3 exponent, okay? Is everybody okay with that? Alright, so what is the fourth root of 81? Well, yes, so 3 times, if you multiply 3 4 times, you do get 81, right? So we are going to get 3. So I have 3 to the exponent negative 3, right? And what do we know about negative exponents? It means what? You take the positive exponent and take the reciprocal of that, right? So this would be 1 over 3 cubed. And then what is 3 cubed? 27. So then our final answer is 1 over 27. Is everybody okay? All right. Let's look at another one. How about I have 3 to the 21 divided by 3 to the 15? What is that? When you have the same base, different exponents, right? What's the rule? You subtract the exponents. And in this case, what do I get? What is that? 3 to the 6. I'm just going to leave it that way. I don't want to multiply 3 to the 6, okay? I guess we know 3 to the 4 is 81, and then you multiply 81 2 more times with 3, right? Is that making sense? What's that? Yeah. 81 times 9. Yeah, well, let's just write it down. So 9. Oops. 729, is that? Everybody's okay with that? Okay. Okay, so that's B. Let's look at another one. Let's say I have 4/5 to the negative 2, right? In this case, once again, negative exponents means that I can make it positive as long as I take the reciprocal of reciprocal of the base, and the base is 4/5. So what's the reciprocal of that? 5/4. And then I take the square of the numerator, square of the denominator, And what is that? 25 over 16. And D, 5 cubed over 7, 5 to the 7, which is what? Well, it's going to be 1 over 5 to the 7 minus 3, right? Which is 1 over what? 5 to the 4. Is everybody okay with that? Which is about 625? 1 over 625. Okay. All right, so those were easy enough. Let's do another example. Again, this would be a simplification example. So the question is, simplify each expression. And A, let's say I have 3x to the 3/2 y cubed divided by x squared y to the negative half, and I have the whole expression to the negative 2. Okay? Okay. So what should I do in this case? Well, there are various different ways you can start the problem. What I'm going to do is, first of all, raise the numerator to negative 2 and raise the denominator to negative 2 as well, separately. Whoops. Okay. So this would be equal to 3x to the 3/2 y cubed to the negative 2 over x squared y to the negative half to the negative 2. Okay. And next we are going to simply say this is 3 to the negative 2, right? 3 to the negative 2. And x to the 3/2 to the negative 2, right? Y to the 3 to the negative 2. I can do that. So I raise each factor to that negative 2 exponent. Again, some of this you can do in one line if you want to. I'm just showing you every step. Okay, so now I could say that this is 3 to the negative 2. So that's basically what? 1 over 3 squared, right? Is everybody okay with that? Well, let me just keep it the way it is for now. What is that? This would be actually what? Actually, negative 3. This would be y to the negative 6, right? Here I'm going to get x to the negative 4, right? And y to the what? It will be plus 1, right? So I just get y. Is everybody okay so far? Okay, so now what we could do is say that, okay, 3 to the negative 2, that's just 1 over 3 squared, right? Which is what? 1/9. What I'm going to do is take, for the x powers, I am going to subtract the exponents in the following way. X to the negative 3 and minus the exponent in the denominator. And the y I'm going to keep in the denominator. So it will be y to the 1 minus the exponent of in the numerator, right? You guys agree with that? The reason I did that is because I want the exponents to be positive. So because the exponent negative 3 was bigger than the exponent negative 4, I subtracted up in the numerator. Because 1 is bigger than negative 4 for the y, sorry, 1 is bigger than negative 6, that's why I subtracted in the denominator for y. Well, what is that? X to the negative 3 plus 4, right? Which is what? Just x. And then y to the 7, right? And then the 9 that I have there, it's going to go where? Denominator. So that's the final answer. Is everybody okay with that? Any questions at all? Okay, so B, let's say I have y divided by x minus x divided by y over 1 over y minus 1 over x. So that's the quantity that we want to simplify. So what should I do? There are two ways of going about it. One is you can look at the common denominator, add the fractions, right? The other trick that you sometimes see is that you look at the common denominator, you take the common denominator of all the denominators, right? So what are the denominators here? X and y, because x and y, they are the denominators in the numerator. X and y are also the denominators in the denominator, right? So I can use so the common denominator is what? xy. So one trick that you could do is just multiply and divide by xy in this way. So what it does is that when you now multiply each term by xy, what's going to happen? So let's multiply y over x by xy. What do you get? Y squared, right? So you get y squared, right? Because x will cancel out. Is that making sense? So what we are saying here is that, is that if I multiply y over x with xy, right? So then x cancels out, and then you have y squared. And so it's similarly, what's going to happen with x over y? You get x squared. In the denominator, you get x minus y, right? Is everybody okay with that? Okay, now can I factor out the numerator now? Is it possible to factor out the numerator? So what do I get? It should be y minus x, right? So I get y minus x times y plus x divided by x minus y. What's the difference between x minus y and y minus x? Yeah. So this is equal to, if I factor out a negative from y minus x, I get x minus y. And then I can cancel out the x minus y. So we are left with negative y plus x. Is everybody okay with that? Is that okay? Questions, anybody? Okay, another one. I think this is C, right? X to the 5/2 minus 3x to the half, 3x to the half plus 2x to the negative half. Okay, let's say this is what we have. Okay, so how do I simplify this expression here? So this is equal to x to the 5/2. Okay, there are a couple of different ways of doing it, okay? So let me do it in one way first. This is 3x to the half plus, this can be written as 2 over x to the half, right? You agree with that? Negative exponent. Now, in order to simplify this, okay, so there are a couple of things that you could do. So I'm debating which one I should be doing. One is you can make every denominator actually half and adjust, or you can say that, okay, x to the half is the common denominator, because here the denominator is 1. Here the denominator is 1. So x to the half would be the common denominator, right? And now, what do? Well, x to the 5/2 that you have to multiply that with what? X to the half, right? So when you do that, what do you get? X to the 5/2 plus a half is what? 3. And minus, you have 3 times x to the half. So x to the half times x to the half, that's just x, right? And then you have 2, which would be by itself, right? So that's what we get. Is everybody okay with that? Yeah. Because you are multiplying. So here's the common denominator, right? So you're multiplying x to the half with this common denominator. So, for example, let me just do another problem here. Let's say I have 1 over 4 plus 1 over 6, right, that I'm adding. How do you add them? Well, what's the common denominator? Well, I can take the common denominator to be 24 if I want to, or I could take it 12. Okay, so what do you do then? Well, you divide 12 by 4, which is 3. Actually, let's make it a little bit more interesting by putting a 3 here. So if I divide 12 by 4, I get 3, and 3 times 3 is 9, plus I divide 12 by 6, I get 2. 2 times 1 is 2, right? This is how you do it. So whatever the common denominator is, you divide it by each denominator, and you have to multiply the respective numerators by that. Is that making sense? Everybody's okay with that? All right. So that's how we could simplify this expression.
So you wouldn't expect us to take it any more than that?
You can write root of x instead of actually have, but this is it. There is nothing else that you could do. Okay. Yeah. Any questions on that? Now keep in mind that there are other ways I could have done it. I could have factored out x to the negative half. Okay? But essentially the same thing. It's just a different way of writing it. Okay. Next example. And this example, you will definitely use it later. The question is rationalize. The expression 9 plus h root of that minus 3 divided by h. I should say rationalize the numerator, okay? When they say rationalize, it means that whatever roots you have there in the numerator, you want to get rid of the root in the numerator, okay? Rationalize the numerator in this case, because the root is in the numerator. So your goal would be to get rid of that root. Am I making sense? So what trick do we apply to rationalize an expression here? Go ahead. You square it. Well, if you just square it, you are changing the value, right? So I think you're probably thinking about the right way, but you're not telling me that the correct way. Okay. Well, let me just say something here that if you remember this formula, a squared minus b squared is a minus b times a plus b, right? If you have the difference of two squares, you can write it as a minus b and a plus b, right? Yeah. So the idea is that you multiply this quantity, the conjugate of the numerator. By that, the conjugate means that you have the same quantity, but instead of negative 3, now you will have positive 3. But you have to multiply and divide as well, since you don't want to change the value of the fraction. So you're basically multiplying by 1, but 1 in the disguise of that fraction. So what does it do, though? Well, what happens is that, think about this guy as A, this guy as B, A and B. So when you multiply A minus B, A plus B, you know that you're going to end up with the squares of both of them. And because you're going to end up with the squares, you can get rid of the root. Okay. So if we do that, if you don't remember that formula, a squared minus b squared, you could still do it. Just multiply them, right? Just multiply these two. That is, you just FOIL them, right? Using FOIL, you can multiply out. If you multiply out, you'll see that you get the square of the root of 9 plus h, and you get the square of the 3, and in the denominator, of course, you have h times the root of 9 plus h plus that 3, and in the numerator then we get 9 plus h minus 9, and then we get h times root of 9 plus h plus 9. Okay, and this is equal to 9 cancels out, right? And then you end up with only an h, right? So you get h over h times this, and then you can cancel out the h's as well, so you get 1 over root of 9 plus h plus a 3. Is everybody okay with that? So you rationalize the numerator, but you ended up with a root in the denominator, right? Is everybody okay with that? The rationalizing trick, you're going to use it many times in the course. Whenever you have a problem involving roots like this, if you cannot think of anything else, apply the rationalizing trick. See if anything good happens, okay? Everybody is okay with that? Or any questions on that? You guys remember doing this type of things before? All right, so next I will go over some solving equations. The videos that I have in Moodle, in your Moodle course, those videos also have lots of other exercises that I have done. Those videos were made last summer, and I was teaching a calculus course last summer, and then the students agreed to spend extra half an hour with me in the class. So it was a 2-hour class already, and then they also said they would be willing to do that, and that's why I have more stuff there than I could possibly cover here. Okay, so those videos, they have more exercises that I have done, more than what I'm doing here. Okay, I actually went over a lot of the exercises from the attachments in those videos. Okay, so the next type of problems that I want to look at is solving equations and inequalities. So let's say, and let me just say solve, and let's say we want to solve the equation x squared minus x minus 12 equals to 0. What should I do? Was that? No. Yeah, that's a good idea, but it's not going to work in this case. Yeah. Yeah, factor out, you mean? Yeah. You're going to say that factor out, I think, as well. X minus 3.
No, plus 3.
X plus 3 and x minus 4. Everybody remembers how to factor out this quadratics. Do you want me to review that? How am I coming up with, how did he come up with 3 and negative 4? What you do is that you look at the coefficient of x squared. The coefficient of x squared is 1, right? You multiply that with the constant negative 12, what do you get? You get negative 12, right? If you multiply the coefficient of x squared with the constant term, you get negative 12. And then you look for 2 factors of negative 12, so that if you add them, you get this coefficient here. Look for 2 factors of negative 12, so that when you add them, you get negative 1. Am I making sense? So you're looking for 2 numbers, a and b, such that a and b is a times b is negative 12. So you're looking for 2 factors, a and b. But when you add them, you want to end up with the coefficient of x, which is negative 1, right? Well, the choices for a and b would be 3 and negative 4. Because if you have 3 and negative 4, multiply them, you get negative 12. Add them, you get negative 1. Okay? So that's how he's coming up with that 3 and negative 4. Is everybody okay with that? Okay. All right. So again, let me actually do a little bit more steps here, rather than just writing down the factors. Okay, so once I come up with a and b like this, so we see that a has to be negative 4 and b has to be 3. So what do I do then? Well, I write the middle term in this way: negative 4x plus 3x, negative 12. So once I get a and b, I write the middle term as negative 4x plus 3x. And now I factor out from these 2 and this 2. So if I factor out x, I get x minus 4. If I factor out 3 here, I get x minus 4 as well. And I get x minus 4. Now x minus 4 is a common factor, so I can take that out and get x plus 3. Now, do you have to show these steps? No. If you just know the factorization, go ahead and write that down. Okay, so once I have the factorization, I'm done, right? Because when the product of two numbers is 0, one or the other is 0. So either x minus 4 is 0 or x plus 3 is 0, right? And so I get x is 4 or x is 3. Everybody's okay? Yes. Thank you. Negative 3, yes. All right, so let's look at another example. This one would be a little bit more trickier, but quite similar. Let's say I have x to the 4 minus x squared minus 2 equals to 0. How would I solve this? This is not a quadratic anymore. Yeah.
You can do it the same way, but just use it as x squared.
Exactly. So what he is suggesting is the following. We are going to set y to be x squared, okay? And then the equation becomes what?
X.
Notice that I have, x squared for the x to the 4 minus x squared minus 2, which is 0. And so if I set y to be x squared, then I get y squared minus y minus 2 equals to 0. Now I have a quadratic. If you factor it out, what do you get? Y minus 2 times y plus 1. Okay. And now I can plug back in what y is. So this would be x squared minus 2 x squared plus 1. Okay. Now, can I factor out x squared minus 2? I can write it. Well, x squared minus 2 means x squared minus root of 2 squared, right? I guess I didn't have to do it. I could have said x squared minus 2 is 0, then x squared is 2, and x is plus or minus root 2. But if I write it this way, I can factor it out as x minus root 2, x plus root 2, x squared plus 1. It's just like if I had x squared minus 2, right? If I ask you to factor out x squared minus 4, wouldn't you say x minus 2, x plus 2? Same way, if I have this, I can still say x minus root 2, x plus root 2. And so either x minus root 2 is 0 or x plus root 2 is 0 or x squared plus 1 is 0, right? So I get either x is root 2 or x is negative root 2. And notice that there isn't a value of x for which x squared plus 1 could be 0, right? Well, we're not working with complex numbers, remember that. So there is no real value of x which will give you 0. Because x squared plus 1 is always what? Positive. Right? So I don't get any, we don't get any solution from there. Okay, no solution from there. So these are the only solutions. Is everybody okay with that? Any questions at all?
Did we just put plus or minus? Radical?
Oh yeah, you could write plus or minus. Yeah, there are many steps that you don't have to worry about writing. Okay, you can write it. Okay, there was B, right? And C is I'm going to try to solve a inequality. Okay, so let's say I have the inequality x squared plus x plus 2 larger than 0. That's the inequality that we would like to solve. So how do we do it? Anyone remembers how to do that? Notice that I cannot factor it out, right? You can't factor it out. So what can I do here? What's that? It's not an equation. Complete this square. Very good. In this case, what you need to do is complete the square, use the complete the square trick, which is the following. What I'm going to do is, first of all, I'm going to take the 2 on the right right side. So this would be x squared plus x larger than negative 2. Right? Now I'm going to try to complete the square for that x squared plus x. Okay? So how do I complete the square? Well, the x squared plus x that I have, I am going to keep that, and then I am going to look at the coefficient of x. What's the coefficient of x? 1. What is half of that? What is the square of that? And I'm going to add that 1/4 on both sides. Did that make sense? Look at the coefficient of x, 1. Take half of it, half. Square that, you get 1/4. And that's what I added here. And now what? Well, what you can realize is that this is in fact x plus half squared on the left. But if you don't realize that, then what you have to do is, we are not used to factoring out something with a fraction here, right? So I'm going to multiply both sides by 4. Okay, so if I multiply both sides by 4, what do I get? 4x squared plus 4x plus 1. By the way, what is this right-hand side? Minus what? So if I multiply by 4, what do I get? Negative 7. Can you factor out the left-hand side? Well, it's the same trick as we used before, right? You multiply the coefficient of x squared and the constant term 1, so you get 4. So you're looking for 2 factors of 4 such that when you add them, you get the middle coefficient, right? Am I making sense? So again, you multiply the 4 and the 1, you get 4. So you look for 2 factors of 4 so that when you add them, you get the middle coefficient, which means that we are looking for a and b with these equations here. Well, a and b should be what? 2 and 2, right? So I know I can see that a has to be 2, b has to be 2, and so the trick is write the middle term as 2x plus 2x. So write the middle term as 2x plus 2x, right? And now you're going to factor out whatever you can from the first 2 terms and the second 2 terms. So from the first 2 terms, I can factor out what? 2x, so I get 2x plus 1. From the second 2 terms, all I can factor out is what? 1. So I get 2x plus 1 here. And now I can factor out 2x plus 1, and I'm left with 2x plus 1 greater than negative 7, right? Is everybody okay with that? Okay. And what do I get? I get 2x plus 1 squared is larger than negative 7. Is everybody okay with what we did so far? Let me make sure that I didn't make any mistakes so far. X squared plus x plus 2 and I took it to the negative 2, that's fine. And we added 1/4, so that's negative 7/4. Again, 1/4 was, I look at the coefficient of x, take half of that, and then square that. So that's how I got the 1/4. Yeah.
If you knew that 9x squared plus x plus 1/4
is x plus half squared.
Yeah, you could just.
You could have done that.
Equal to negative 7/4.
Yeah. You could have done that, okay? So now my question to you is that now we came to this inequality here, right? So for what values of x is this inequality true? For what values of x will this inequality be true? Well, notice that the left-hand side is just a square, right? It is positive while it is non-negative, right? And the right-hand side is negative, so the left-hand side is always bigger, no matter what x is, right? So that's why x could be anything. So here, all I could say is that x is in negative infinity to infinity. I didn't have to do much work here. If the 7 was a positive 7, what would I do? I would be taking the root on both sides, right? Am I making sense? So, but I don't have to here because the right-hand side is negative 7. Is that making sense? Now, oftentimes you'll see that the right-hand side is not negative, it is positive. In that case, you do have to take the square root. Any questions so far? Let's see how much I've finished. This is where I am right now. Okay. That was what? C or D? Okay, a couple of minutes left. Let me try to do something quickly here. 9 minus x squared is larger than 0. That's what I want to solve. What I intended to write x squared minus 9. Okay, so how do... No, before I had 9 minus x squared, so it will be different. Yeah. So x squared minus 9. There are a couple of different ways of doing this, okay? One would be that you can just write x squared is greater than 9, right? And now you take the square root of both sides. So when you take the square root on both sides, remember I said when you take the square root of a number, you get the positive root, right? So on the right hand side, I'm just going to get 3. What do I get on the left? Actually, I should be writing absolute value of x, because I don't know what x is, so I should be putting absolute value of x because I want to take the positive root of x squared, right? Positive root of x squared. So then I get the inequality, the absolute value of x is greater than 3, but then what does that mean? It means that x would have to be what? Let's look at the number line again. If this is the number line, let's say this is 0. Let's say this is negative 3 and this is positive 3. If absolute value of x is larger than 3, then it means that the distance from 0 to x is bigger than 3, right? If the distance from 0 to x is bigger than 3, then x would have to be where? Here or here, right?
Yeah.
So that means we are saying that x is either here or x is here. Okay, so just a last thing to say is that this means that x is either larger than 3, or let me first write the other one, x is less than negative 3, or x is larger than 3. How would I write this solution set in interval notation?
Negative infinity to 3.
Yeah, negative infinity to negative 3. Because I have a strict inequality, I put parentheses, and together with 3 to infinity. That's how we would write that down. Is everybody okay with that? So that's how you want to write your final answer. You guys are remembering stuff? Okay. All right, so have fun this weekend, and we will continue on Wednesday with the review, and we are going to continue reviewing until Friday. Okay.